Okay, folks, today we're going to do two examples of what if I give you the algebraic expression and what we could use with that algebraic expression. So here, if we look at these examples here, we could see that we have tiles equals 3n minus 1 and tiles equal 8n plus 6. And then we could solve for these questions. So if we look here at this one, tiles equals 3n minus 1. Remember, n in this case could be any number, any case number. This, again, n could represent case. I've been using cases, so let's talk about that. It could be represent case, figure, or position, anything like that. So if we look at tiles is equal to 3n minus 1, if I had case 1, can anybody know how many tiles there are? What would you do? What you would do is, well, we know n equals 1. And remember, when we have a number next to a variable like this, it means multiply. So we're going to go 3 times 1 minus 1, which is then going to equal 2. So that means when n, there's one tile, or no, when case 1, there's going to be 2 tiles. Again, we don't know what this looks like, but we just know case 1 is going to have 2 tiles. So then how many tiles would case 2 have? Well, you would go 3 times 2 minus 1, which equals 3 times 2 is 6, minus 1 is 5. So now we're going to have 5 tiles. In case 2, we're having 5 tiles. Notice how the n is changing. N was 1, now n is 2. So in this one, n is 3. So 3 times 3 minus 1 is equal to 7. Oh, 3 times 3, that's wrong, is equal to 8. Sorry about that. It's equal to 8. 3 times 3 is 9, minus 1 is 8. Yes. So this would be 8. Now we have, okay, case 1 has 2 tiles. Case 2 has 5. Case 3 has 8. Now what we could do with these numbers is actually plot them. So where we have case, let's say on the bottom here, and we have tiles along the side. So in case 1, there are 2 tiles. So we're going to put a plot point right there. In case 2, there are 5 tiles, so we're going to put a point right here. And in case 3, there are 8 tiles, so we're going to put a point right here. Now we notice that this forms a straight line. It forms a straight line through there, okay? So that forms a straight line. And then we could say, okay, in case 10, or case 4, if we look at case 4, it goes up here and should be 11 tiles. And if we do the math, we would find 11 tiles for case 4. So that's what the benefit of a graph. So let's do this again. I want you to try this one. Try to do everything and then check your answers with me. So in case 1 and 1, we're going to go 8 times 1 plus 6. 8 times 1 is 1 plus 6 is 14. Here we have 8 times 2 plus 6 is 1622. And we could do this for 8 times 3 plus 6 is equal to 30. So we have this pattern here. And if you look at my graph, I used the wrong legend, so I'm going to just change that. Right? Let's go up by 5s this time. I'm going to go up by 5s because we're going all the way at 5, 10, 15, 20, 25, 30. Okay, and this won't be perfectly uniform because I didn't use a ruler for this, but 1 is 14, so that's going to be right there. 2 is 22, so that's going to be there. And 3 is 30, so that's going to be right there. And as we see, this forms a straight line going through all of them, like so. So here just shows some examples of how we could use algebraic expressions to put in points as well as whatever, I can't think right now, as well as graph. Last question is, I might say, well, what about in this one over here, what about the 21st case? Well, you could do this by just putting 23 in. 3 times 21, I mean, minus 1. 3 times 21, well, that's 63 minus 1. So our answer is 62. There. So you could find any case using this. Hope this video helps. Take care and